Okay, so let's take a look at mass with density assignment 1. I will not be going through the details of the definition question. So I'll be focusing more on the application questions and the calculation questions. So for definition question, I will just refer you to the page number on your booklet and you can refer from there. Okay, alright, so for the first question 1a, it says state what is meant by the mass of an object. Okay, I think this you can find it on page 51 of your booklet. So I will not be going through this. SI unit for mass is in kg. Number 2, they ask you to state the relationship between the mass of an object and its inertia. So in the booklet it says that mass is the measure of inertia. So from that we know that the larger the mass, the larger the inertia. Okay, so if you want to understand this concept, you just take an example of you trying to push an adult man and a little boy. So the man obviously has a larger mass than the little boy. So when you try to push both of them, you'll find that it is more difficult to push the adult compared to the child, alright, to the little boy. So because of that, we understand that hey, the larger the mass, actually the inertia is larger. The body is more reluctant to move, even when we apply a force on it. Okay, so for 1c, what is meant by gravitational field strength? This one, I think you can find a definition on page, what is that, 52. Alright, this is on page 52. So it says that it is defined as the gravitational force acting per unit mass. So I'm just going to show you the SI unit. So it is the force acting on the unit mass. So it means that for every 1 kg of mass, the force exerted will be 1 Newton. Okay, so this is what is meant by gravitational field strength. One day they ask you to state the meaning of the weight of an object. This one, I think you can also find it in the booklet. So this should be found on page, let's see, 54. This is on page 54 of your booklet. SI unit for weight. Weight is actually a type of force. So the SI unit of weight will be the same as the SI unit of force. This will be measured in Newton. So for question 2, they asked to state two differences between mass and weight. The entire table can be found on page 55 of your booklet. Page 55. There are 4 listed on a page. However, the question only requires 2. Okay, so I'm just going to talk about the 2 more, the more prominent ones. Okay, the first one given by the question is the amount of matter or in the body for mass. So there's a definition compared to another definition for weight. Alright, so on top of that, I also want you to know that mass is actually a scalar quantity. So do a quick recall. What is scalar? Okay, a scalar quantity means that this quantity only has magnitude. Meaning, it only has a value. It does not include direction. So I will say that my mass is 75 kg. I will not say that my mass is 75 kg due west because the direction does not make sense here. Whereas for weight, weight is a force, hence this is a vector quantity. It has both magnitude plus direction. Okay, another one for mass is SI unit. It's in kg. Whereas for weight, just like I said just now, weight is a force, right? SI unit is in Newton. Okay. The fourth one mentioned in the booklet is talking about whether or not the term or the quantity is dependent on gravitational field strength. So in Sec 2 we learned that mass is always constant, right? So regardless of where you are on Earth or on the Moon, the mass will always be constant. Therefore, this is actually independent of gravitational field strength. On the other hand, your weight is dependent on the gravitational field strength. Okay, so your weight will change. If you take a weight on Earth and then after that you decide to fly to the moon, you take a weight there, you realize that your weight will not be the same. However, mass will always be a constant. So let's take a look at question 3a. Okay, I think this is the first calculation question. So we're going to make use of the relationship. Okay, they ask you to state the equation that relates weight of an object, okay, weight to its mass and the gravitational field strength. Okay, so these three, when we put them together, the formula is W is equals to mg. So to find a weight, it is the product of the mass of the object and the gravitational field strength where the object is. M, SI unit is kg. G, SI unit is Newton per kg. So the SI unit for your weight will be Newton. Alright, so you need to be very careful with how you handle the units of the quantities given to you. So I think question 3b is it gives very good examples. So let's take a look. They tell you that we are given 4 different masses, A, B, C and D. We are to calculate the weights on Earth and on the Moon. Alright, so they say show your working. They bolded for you, but I seem to highlight this in a table clearly. So let's write the equation here so that we don't have to scroll everywhere. W equals to mg. Okay, we need to show the working. So let's do the weight on Earth. Let's do A first. Alright, so W equals to mg. So m in this case given 45, g is 10. Very straightforward. This is 450 Newton. So let's do the same for the weight on the Moon. W equals to 45, but the g on the Moon is not the same as that on Earth. It is 1.7 given by this question over here. So let me recall. This is, I think, 76.5 Newton. Okay. B, 2.8 kg, same thing. W equals to 2.8 multiplied by 10. I get 28 Newton. For this, I get 2.8 multiplied by 1.7. I get 4.76 Newton. Alright, for C and D, we need to be very, very careful. Okay, national exams, they are usually quite tricky. They tend to play around with units a lot. So you need to be very observant and look at what units are given to you and what units are required of you. So for C, over here. Alright, we are not given 78 kg, we're given 78 grams. So there is a need for us to convert this gram into kg before we calculate the weight using the formula. So of course we can put everything in one step. Let's convert grams to kg. What do? We divide by 1000. Right? So same, we're going to multiply by 10, which is the g. In this case, the answer will be 0.78 Newton. Okay, right, the same thing applies over here. 78 over 1000 straight away is converting my grams to kg. Multiplied by 1.7, be careful, not 10. I get 0.133 Newton. Last question, last part, 4.6 gram, same thing. 4.6 divided by 1000, multiplied by 10, I get 0.046 Newton. And then for the weight on the Moon, W is equals to 4.6 over 1000 multiplied by 1.7. Answer is 0.00782 Newton. Okay, sometimes your calculator may give you in standard form. So if that's the case, the answer should be 7.82 multiplied by 10 to the power of negative 3 Newton. Okay, you can leave your answer in either way because there is no special request from the question. Okay, let's move on to look at question 4. It says that the gravitational field strength on the Moon's surface, okay, the Moon's surface is smaller than that on Earth's. Alright, they did not give us a specific number. Alright, but what we do know is that the G on Moon is less than the G on Earth. Okay, so they want us to state whether the following quantities decrease, increase, or remain unchanged. Okay, so the first one is mass of the rock. So mass, remember we said it was independent of the gravitational field strength. Mass will always remain a constant. Okay, so in this case, answer will be remain unchanged. Alright, as I was marking, I realized some of you like to use your own phrase or your own words. The question gave us specifically, alright, to use the word decrease, increase, or remain unchanged. So please follow the question, okay? Next, we are to talk about the weight of the rock. Alright, so weight, W equals to mg, it will change according to the gravitational field strength. So, since the rock is being brought from Earth all the way to the moon, which has a smaller g, okay, the weight of the rock should decrease. Right? And lastly, talk about the volume of the rock. Okay, so far we have been talking about mass and weight, nothing on volume, right? Okay, so just think logically, alright, when we try to bring the rock from the Earth to the moon, the question never mentioned anything about crushing it or about the rock disintegrated. So of course in this case the volume should remain unchanged. I think I had the spelling already. Okay. Alright, let's take a look at 5A, the last two parts for this assignment. A boy weighs 560 Newton on Earth. They want us to calculate, so same, calculate his mass on the moon, given that the gravitational field strength on Earth is 10 Newton per kg. Alright, note the question talk about weight on Earth. However, they ask us to find the mass on the moon. Alright, so does it really matter? Given the weight on Earth, I can find the mass on Earth as well. So after I find the mass on Earth, because we understand that mass will always be a constant regardless of where we are, okay, the mass on Earth will be the same as the mass on the moon. So same thing, W equals to mg. Please throw in the formula, the first thing you do for all calculation questions, okay? Writing in the formula will guide you well so that you will be less likely to commit careless mistakes. Okay, so but the question wants us to find mass, right? So let's do a bit of manipulation. M is equals to W over G. Bring the G over. Okay. So in this case, mass is equals to 560 divided by 10. How do I know 10? Because the question says so. Alright, get 56 kg. Very easy. Okay, let's move on to 5B. Calculate the weight of the boy on the moon, given that the gravitational field strength on the moon is 1.6. Okay, so this is the part. As I was marking, I see so many of you using 1.7 Newton per kg as the value of G on the moon. And I can only guess that because that's the value given to you in 3B. So you just assume that the value will be the same throughout. Okay, so please read the question carefully. For this part, the G for moon is 1.6 and not 1.7. Alright, so again, because they use the word calculate, I'm going to show my working. W equals to mg again. Okay, I don't have to do any manipulation now because it's exactly what we want it to be, weight. So W equals to 56, the mass is a constant, multiplied by 1.6. Okay, what do I have? It is 9.6 Newton. Okay, so with this, we shall end the tutorial for assignment 1. I hope you guys are okay with this. If not, you can always look for me for consultation.